Assalamualaikum and salam sejahtera to my lecturer, Professor Madya Dr. Ahmad Nazri bin Dagang. My name is Nur AQILA binti SHOKI, matrix number S60859. In this video, I'm going to talk about Thyristor, Igbt, integrated circuit and Cmos. For the first part, I'm going to talk about Thyristor, which is known as silicon control rectifier. The Thyristor is a 4-layer, 3-terminal semiconductor device which each layer consisting of alternate N-type or P-type material, for example PN. 4-layer device act as either open or closed switches. For this reason, they are most frequently used in control application. They stay on one state trigger and will go off only if current is too low or when trigger off. The CSR is the most widely used and important member of the Thyristor family. The CSR is almost universally referred to as Thyristor. As you can see from this figure, it has 3 terminals, which is anode, cathode and gate. In off state, it has a very high resistance, and when in on state, there is a small on resistance. It is constructed by silicon material with 3 terminals for control. Let's continue with the working of a Thyristor. When anode voltage is positive with respect to cathode, junction J1 and J3 are forward bias, and junction J2 is reverse bias, and the Thyristor is off. This state is called forward blocking state. When the voltage is increased, the reverse junction breaks and it is called forward breakdown voltage. In this state, a large anode current flow and the Thyristor is said to be on or in conducting state. This is the appearance and schematic symbol of Thyristor. For the second topic, we will continue with Igbt, which is insulated gate bipolar transistor. The insulated gate bipolar transistor, also called an Igbt for short, is something of a cross between a conventional bipolar junction transistor and field effect transistor, making it ideal as semiconductor switching device. Igbt are mainly used in power electronics applications such as inverter, converter and power supply, where the demands of the solid-state switching device are not fully met by power bipolar and power MOSFET. High current and high voltage bipolar are available, but their switching speed are slow, while power MOSFET may have higher switching speed, but high voltage and high current devices are expensive and hard to achieve. The Igbt transistor takes the best part of these two types of common transistor, the high input impedance and high switching speed of a MOSFET with the low saturation voltage of a bipolar transistor, and combines them together to produce another type of transistor switching device that is capable of handling large collector emitter currents, which additionally zero gate current drive. We can see that the insulated gate bipolar transistor is a 3-terminal transconductance device that combine an insulated gate and channel MOSFET input with a PNP bipolar transistor output connected in a type of Darlington configuration. As a result, the terminals are labeled as collector, emitter and gate. 2 of its terminals, which is collector and emitter, are associated with the conductor's path which passes current, while its third terminal, the gate, control the device. For the Igbt characteristic, it only requires a small voltage on the gate to maintain conduction through the device, unlike BJT, which requires that the base current is continuous, supplied in a sufficient enough quantity to maintain saturation. The principle of operation in gate drive circuit for the insulated gate bipolar transistor are very similar to that of the N-channel power MOSFET. The basic difference is that the resistance offered by the main conducting channel when current flow through the device is on state is very much smaller in the Igbt. Because of this, the current ratings are much higher when compared with an equivalent power MOSFET. Also, the Igbt is an unidirectional device, meaning it can only switch current in the forward direction. That is from collector to emitter, unlike MOSFET which have bidirectional current switching capabilities, which is controlled in the forward direction and uncontrolled in the reverse direction. For the third topic, we are going to talk about IC, analog and digital. IC are the tiny electronic circuit used to perform the several operations like amplifier, timer, counter, oscillator, microcontroller or a computer memory. It is formed as a single unit by diffusing impurities into the single crystal silicon, which then serves as a semiconductor material. Upon the IC, there is several active components such as transistor and diode, and basic component which is resistor and capacitor. Integrated circuit has their own size, which is the small scale integration up to 100 components, medium scale integration up to 100 until 3000 components, large scale integration 3000 until 10,000 components, very large scale integration 10,000 until 100,000 components, and ultra large scale which is more than 1 million. There are 2 types of integrated circuit, which is analog and digital. For digital integrated circuit can contain anything from 1 to million of logic gates, flip-flop, multiplexer, and other circuits in a few square millimeters. The small size of this circuit allows high speed, low power dissipation, and reduce manufacturing costs compared with board level integration. This digital IC, typically microprocessor, DSP, and microcontroller, work using binary mathematics to process 1 and 0 signal. For the analog, Analog such as sensor, power management circuit, and operational amplifier work by processing continuous signal. They perform functions like amplification, active filtering, demodulation, and mixing. Analog integrated circuit is the burden of circuit designer by having expertly designed analog circuit available instead of designing a typical analog circuit from scratch. For the last topic, we are going to talk about complementary metal oxide semiconductor, which is CMOS. As you can see from this figure, this is show the NMOS and PMOS operation. For the NMOS operation, body is commonly tied to ground, which is 0 voltage. When the gate is at a low voltage, P-type body is at low voltage. Source body and drain body diode are off, and there's no current flow, which is the transistor is off. And for PMOS operation, it's similar but dropping a voltage reverse. Body tied to high voltage. When the gate low, the transistor is on, and when the gate high, the transistor is off. That's all from me. Thank you for having your time. Arigato sensei.